Hi National 4-5, welcome to Homologous Series Lesson 8. Okay, so as usual, there's a wee starter for you to do, so I'm going to go through the questions and then you can pause the video and then complete the questions. So question 1, I want you to copy and complete. So you've got an alkene here, you're adding hydrogen, what product do we get? I want you to draw the product. Question 2, what type of addition reaction is in question 1? So remember, we're adding hydrogen, so that should give you a clue as to what type of addition reaction it is. Question 3, what word can be used to describe these two compounds? So we've got butane and we've got 2-methyl propane. What can be used to describe those two compounds? And then question 4, what is the definition of this word? Okay, now remember, we've only learned 2 definitions. It's got to be one of them. Question 5, what 2 products are formed in complete combustion of a hydrocarbon fuel? So remember, complete combustion means we're burning the substance in a plentiful supply of oxygen. Okay, so pause the video, do the questions, and then unpause it because I'm just about to go over it. Right, first question, we are adding hydrogen. Now remember, we can draw H2 out like so, yeah, H bonded to H. Now what happens, that H there can bond to that carbon and that H there bonds to that carbon. Remember, in addition reactions, it's the carbon to carbon double bond that breaks. Okay, so what we are left with, if I just draw out our molecule again, so the carbon to carbon double bond breaks, and all we're doing is we're just adding the hydrogen like that. So we're going from propene to propane, yeah, just like that. Right, what type of addition reaction is in question 1? We're adding hydrogen, so that is hydrogenation. Okay, and you need to know that. If we were to add chlorine, it would be chlorination. If we were to add bromine, bromination. If we added water, hydration. Okay, right. Question 3, what word can be used to describe these 2 compounds? They are isomers. Okay, and why are they isomers? Well, this kind of answers question 4. They've got the same molecular formula, yeah, they've both got C4H10, but they've got different structural formulae. And what do we mean by that? It means, well, they've got a different structure, they've got a different name. Okay, so butane, 2-methyl propane. Okay, question 5, what 2 products are formed in complete combustion of a hydrocarbon fuel? Well, that is carbon dioxide and water. Okay, if it was incomplete combustion, so the fuel is burned in a limited supply of oxygen, we would get carbon monoxide plus water. Okay, so that's your answers there, just in the one place. That's your definition of isomers. I know I never drew it up there, but compounds with the same molecular formula but different structural formulae. So mark that, see how you get on. Hopefully you're getting the most of them. Right, what we're going to do now is we're going to do another homologous series, my favourite homologous series, alcohols. Love the chemistry of alcohols. Right, so we'll make a wee note so you guys write what I'm writing. So alcohols are another type of homologous series. Okay, and what do we mean by homologous series? You should know the definition. Family of compounds with the same general formula and similar chemical properties. Yeah, just like that. Right. So you've got similar, the same general formula and similar chemical properties. General formula, okay, for alcohols is CnH2n plus 1 OH. Okay, I'm not going to talk about that just now, we will come back to it. Okay. Right. This is probably one of the most important parts about alcohols. Alcohols contain the functional group called the hydroxyl group, okay, and it looks like that. So an O bonded to a H. So we'll highlight that. Now, you know what function, you should know what a functional group is, okay, because we did functional groups when we did alkenes. Yeah, the functional group is just what gives the group its property essentially. So the functional group for alkenes is the carbon-to-carbon double bond. The functional group for alcohols is the hydroxyl group, okay, and you all need to know about the functional group of an alcohol, okay, the hydroxyl group. A lot of people forget that and they get it mixed up with the carboxyl functional group, which we'll do later. So make sure you're in a position where you know that alcohols can contain the hydroxyl group OH. Okay, now I just want you to make a wee note here. Note, alcohols are not hydrocarbons. Now we've done 3 hydrocarbons. We've done alkanes, alkenes and cycloalkanes. Now, why do you think alcohols are not hydrocarbons? Remember, what's the definition of a hydrocarbon? It contains hydrogen and carbon only. Okay, what do alcohols contain? They contain oxygen as well. So just a wee note, remember that alcohols, sorry, I'll put that up there. Alcohols are not hydrocarbons. Okay, just remember that. Right, let's get back to this then. All alcohols end in all. Okay, and I'll explain what we mean by that. So we're going to just do a wee table here. So name molecular formula, full structural formula, and shortened. I'm running out of space, but shortened structural formula. Okay, so if I just Right, so the very first alcohol we have is called methanol. Okay, so the first alkane is called methane. Okay, so what we do is we remove the E and we add ol. So this becomes methanol. Okay, the next one would be ethanol, etc. Okay, so our molecular formula, we'll all come back to that. We'll draw the full structural formula first. So meth tells us that there's one carbon. Okay, now because it's an alcohol, it has to contain the functional group OH. So we draw that OH in, so it's C bond O bond H. Okay, then all we do, like we do with everything, we just fill our hydrogens in. Now remember, carbon's got a valency of 4, so it can only bond to 4 other atoms. So we've already got a bond there, so we put a H all around it, and then that way carbon has filled its valency, and then that's how we draw methanol. So our molecular formula would be CH3OH. Okay, we always keep the OH separate. Yeah, and that tells us it's an alcohol because it's the hydroxyl group. Now if we want to shorten that, like we do with alkanes, alkenes, etc., we draw a line down like that, and then what do we have on the left? We have CH3 bond OH. Yeah, and that's it. So I'm going to go into the next one. So first one was methanol, the next one is ethanol. Okay, now eth is the prefix for 2 carbons, so we draw 2 carbons. 1, 2. It's an alcohol, so it contains an OH, so we draw that. Okay, and then we just fill in our hydrogens all around, like so. Yeah, relatively straightforward. So if we want to write the molecular formula, how many carbons do we have? We've got 2, so that becomes C2. How many hydrogens? 1, 2, 3, 4, 5. H5, and then we've got the OH, remember, at the end. Yeah. Now, if we want to draw the shortened structural formula, we need to split this up, like so. Now the first one we see is CH3, the next one is CH2, and then the last one is OH. Okay, now it's up to you whether you want to put the bonds in or not, like what we did here. You can either write it like that, or you can put the bonds in like so. It doesn't actually matter. Right, now the next one, this is where it gets a wee bit more complicated, but I feel like we've already covered it in a way. Okay, now the first one, I'm going to draw. Okay, so that's 1 carbon, 2 carbons. The next one is 3 carbons. Okay, so we can draw our alcohol like that, and then we can add in the hydrogens like so. Okay, now I'm just going to draw another line here, because you'll maybe have noticed that that carbon there is the only carbon that OH can go on. That carbon is the only carbon that OH goes on. If we were to draw the OH on that carbon, it's the same molecule, just flipped over. Okay, however, on this carbon, the OH can go there, but it could also go on the middle carbon. Okay, so we're going to draw that. So it goes on to the middle carbon, like so. So you'll notice we've got the OH there, and we've got the OH there. So on two separate carbons. Yeah. There and there. Now, both of these have the same molecular formula. They've both got 3 carbons. They've both got 7 hydrogens, and they've got an OH. So the molecular formula for these are exactly the same. The only thing that's different is the structure. Okay, so these two here are isomers. Okay, because they've got the same molecular formula, but they've got a different structural formulae. Okay, now if I wanted to do the shortened structural formula for this one, again, I'll split this into 3 sections, or 4 sections actually. So this becomes CH3, CH2, CH2OH. Okay, this one is a wee bit different. Okay, so in that section there, you've got a CH3. In the next one, you've got a CH. Okay, and what else is bonded to the C? An OH. So this is a branch, essentially. So you need to put branches, if you can remember, in brackets. And then the next one would be CH3. Okay, so it's kind of bringing in everything that we've known. Now, how do we name these? Okay, so they've both got 3 carbons, so they're both called propane, like that. Okay, now you think you would call it propanol, but because the carbon position has changed, we need to specify that. Now, remember, when we're naming alcohols, it's very important that we start from the side closest to the functional group. Okay, so in this case, we start on the right. So that carbon there is carbon 1. The next carbon is carbon 2. And then that one is carbon 3. Okay, and this one here, it doesn't really matter where we start because the OH is always going to be on carbon 2. So we have to specify that. Now, that OH is on carbon 1, so we call that propan 1-ol. Okay, so propan-1-ol. Okay, so this one, what do you think this is called? It's on carbon 2, so it's propan-2-ol, propan-2-ol. And that's it. Yeah. So we're going to do a couple of questions. So draw butan 2-ol. Okay, so we'll do it together. You can pause the video if you want, you can do it yourself, but we'll do it together. So but means 4, so we need to have 4 carbons. 1, 2, 3, 4. Now, it's 2-ol, so that tells us that the hydroxyl group, the OH group, has to be on carbon 2. Now, it's up to you what you want to make carbon 2. You can start on the left or you can start on the right. It doesn't really matter. I'll start on the right. So 1, 2, 3, 4. Yeah, so the OH is on carbon 2. And then the rest of the hydrogens are all around. Okay, I want you to make this wee note here because this is very, very important. The O is bonded to the C, not the H. Okay, so what we mean by that is that we draw it like that. Okay, we don't draw it like that. Okay, you will lose a mark for that. Okay, you need to make sure that the carbon is attached to the O. So if we were to draw it this way, we would do that. Yeah, that's right. But if we were to do it like there, that's wrong. Okay, the carbon has to be bonded to the O. It can't be bonded to the H. And a lot of people make that mistake and they lose a mark for it. It's such a silly mark to lose. Okay, so that's question 1. Question 2. Draw a... Now this is a hard question. I'm not expecting anyone to get this, but we are going to go through it together. Draw a branched isomer of butan 2-ol. Okay, now we couldn't draw butan 1-ol here because that's a straight chain. Yeah, we're trying to draw a branched isomer. So remember, I don't know if you can remember with isomers, if we've got 4, if we want to create a branch, we make our longest chain 1 less than the straight chain. So if the straight chain's 4, to get a branched isomer, we make the longest chain 3. Okay, now remember it is an isomer, so it has to have the same molecular formula, so we put the carbon as a branch. Okay, and the OH, it's totally up to you where you can put it. You can put it on carbon 2, you can put it on carbon 1, it doesn't really matter. I'll just put it here. And then if we fill in our hydrogens, there you go. Okay, and how do we name that? Well, we start from the side closest to the functional group. Now remember, if we've got a branch and a functional group, the functional group always takes priority. So we start there, 1, 2, 3, and then our branch we can circle. Okay, so let's name the straight chain first. Straight chain is 3, so it is propan, and the OH is on carbon 1, so we call that propan 1-ol. Yeah, now this here, we have 1 carbon in our branch, so our branch, remember, would be methyl. Yeah, meth, and then il at the end. And what carbon is it on? It's on carbon 2, so we call that 2-methyl propan 1-ol. And that's it. Yeah. We'll do question 3. Draw 2,3-dimethyl pentan 2-ol. Okay, so we'll do this together. Now, the pent tells us that there's 5 carbons, so it's 1, 2, 3, 4, 5. Okay, it's up to you what side you want to make carbon 1. I'll just start from the left, so 1, 2, 3, 4, 5. It's pentan 2-ol. Okay, so the hydroxyl group, the OH, is on carbon 2. Now remember, the bond to the carbon has to be bonded to the O. Okay, so we've got pentan 2-ol. Now this part is 2,3-dimethyl. Okay, so methyl group is just a CH3, but because it's di, we have 2 of them. Okay, 1 on carbon 2, 1 on carbon 3. So we have a CH3 here, and we've also got a CH3 on carbon 3. Yeah, then all we have to do is fill in our H's all the way around, and there you have it, 2,3-dimethyl pentan 2-ol. questions 2. Okay, so these are questions that I want you guys to do. So very first one, I want you to name and draw the functional group of an alcohol. Okay, question 2, I want you to write the general formula for alcohols. Okay, but you might want to go back, look at your notes for that. The general formula, remember, general formulas always start with CN, so you need to have a wee look for that. Question 3, I want you to draw A, ethanol, B, hexanthreol, and then C, 3-ethyl pentan 1-ol. Okay, that's 3. That's horrible, that actually. That's 3-ethyl pentan 1-ol. Okay, pentan 1-ol. And then 4, I want you to name these molecules. Right, I want you to try those questions. Pause the video because instead of posting the answers later, I'm just going to go over the answers now. So I want you to pause the video and I want you to try them, then I'm going to go over it. Okay? Right, question 1. Name and draw the functional group of an alcohol. The name is the hydroxyl group. Okay? Hydroxyl group. And if we want to draw it, we go for bond OH. That's it. The general formula for alcohols, CnH2n plus 1 OH. Yeah. If we want to draw ethanol, eth is the prefix for 2, so that's 2 carbons, and it doesn't actually matter where you put the OH as long as it's connected to a carbon. There you go, like that. B, hexanthreol. Hex means 3, 1, 2, no, sorry, hex means 6, 1, 2, 3, 4, 5, 6, and it's on carbon 3, so 1, 2, 3. Now, if you started on that side, 1, 2, 3, and drew the OH on that carbon, that would still be right because it would just be the same molecule but flipped over. Okay? Like so. And C, where are we? 3-ethyl pentan 1-ol. So pent means 5. So 1, 2, 3, 4, 5. The alcohol, the hydroxyl group, sorry, is on carbon 1. So that is OH. So, and then the ethyl group is on carbon 3. So 1, 2, 3. Now, remember, ethyl means a branch with 2 carbons in it. So it's going to look like that. Okay, so it's got 2 carbons and the hydrogens are all the way around. And then, once you've done that, very simple, just draw your hydrogens in. Okay, right, let's name these 2 molecules. Now, longest chain is 3, so that's propane, and it's on carbon, the hydroxyl group is on carbon 2, so that's propan 2-ol. Yeah, propan dash 2 dash ol. Now this one here, what side do we start at? Do we start at the side on the left or on the right? We start on the right. Why? Because it's closest to the functional group. Yeah, functional groups take priority over branches, so we label the longest chain from the right hand side. So that is butane, and the functional group is on carbon 2, so it's butane dash 2 dash ol, and the branch is on carbon 3. Now it's a branch with only 1 carbon, so we call that methyl. So that becomes 3, because it's on carbon 3, 3 dash methyl butane dash 2 dash ol. 3 methyl butane 2-ol. And that's it. Okay, I'm going to put some extra questions on Teams so you can have a wee go at that. Right, thank you.